All right, today we're just going to start by introing these log properties that exist for 3.4. We're going to wait to do some of the examples till we are in person and fully back face-to-face, believe it or not, except for obviously distance and home learners will be on the computer. But we want to save some of the practice for that time, but get some of these properties down just to save ourselves time and give us more opportunities in class for questions and practice and that kind of stuff. So starting off with these properties, as a reminder of what logs are, we'll kind of start with that. So logs, again, are the inverse of exponentials, meaning if you have an exponential function, we can convert it, those are arrows, sorry, to log. Your base still is your base in this case, but now it's that little subscript. And then with an inverse, x's and y's, or input and output, are switching. So what was, your x was your input, that now becomes your output, and the y as your dependent, your output, is now the thing plugged in there. Another way to kind of remember this, to kind of help you, is like the b and the x are next to each other. If I were to put the x here, they're still right next to each other. And if we're doing an inverse, you should have things, well, in this case, x and y, switching, and so you should not have like a b to an x still in a log. Nothing would have switched in that case. So either way you remember it is fine. Just this is something that will definitely need to be memorized. You're going to use it excessively over the next couple sections to help you memorize it, but you're definitely going to need to know that. Okay, so with the logs then, there's kind of 4 properties that come about. And you can memorize, or again, you can figure them out by understanding exponentials. So your first one is that log base b of 1 is 0. Okay, now just over on the side here, I'm going to put your like exponential equivalent, just so you can see how you don't have to memorize these, you can figure these out. So if I switch this to my exponential format, b is my base, 1 is my input, so that's now my answer. 0 is my output, so that's now my power. And you're very familiar with exponentials. We've been doing them. You've had them in many previous math courses. Anything to the 0 power is 1. And so these two things say the same thing, just in the inverse format with that log. Okay? Your second one is that log, that's a log, base b of b is 1. So again, doing our exponential format, your base is b, your output was 1, so that's now my input, and then my b, so this is this b here, and b to the first is b, which again, you are all very well aware of there. Okay, third one is log base b of b to the y. So I'm going to put an exponential inside my log. This thing is going to equal y. I know, again, let me show you how that is true. Your base is b, so still sticking with that b. My output was y, so that's my new power. My input was b to the y, so b to the y. And b to the y equals b to the y. Okay, 4, if b is, now this is like an exponential, so this is my base. My power, my exponent, is going to be log base b, and I'm going to put an m in there. That thing is going to equal m. Okay, these two especially, it's weird. They're almost too easy that they're hard because they're almost too easy. But when I do the switch again, since this is an exponential, so this is kind of not a log property per se, but the log's up here. This, when I switch to a log, would be log base b of my output, so m, equals my input. Now in this case, your input is actually a log. That's what's being plugged into your power. And just like the first one, log base b of m equals log base b of m. So you will get 3 and 4 here. You will get versions of these. They're going to put numbers in there. There's not going to be all letters like we have here. But you will get some that kind of simplify to this type of thing, and then you can compare powers or compare inputs and solve some of those. So. All right, now in terms of properties, those are more, I don't know, rules is the right, or properties. These are going to be ones that don't have connections to exponential. These are your logarithmic properties. Okay, there are 4 of them that we're going to talk through, and then like I said, we'll practice when we come back full face-to-face. So the first one is called your change of base, and so this rule, again, is new to you. So let's go, it's going to be log base b of x equals log. Now I'm going to change my base, hence the name of the property. I'm going to just use a, but you can put any number you want here. You can put a common log with a 10. You can put a natural log with an e. You can put a 17. We're not going to go negatives and things, but we can put any number, positive number there. Okay, and then of x divided by log base a, and these do need to be the same of b. Okay, so this is one of our properties that if I'm evaluating a log, I can change my base by doing division. The log of the input goes on top, the log of the base goes on the bottom, and then I get to pick what that a value is. Okay, so for example, that kind of helps clarify a lot of these properties. This log, I can switch to log, and I can put any number I want here. We use this because on our calculator, if you have that TI-83, you only have a common log option, which is that key that says LOG. You only have that as an option. You don't have the change of base with the newer model. So if you have an 84 or up, if you hit math and go down your list or up to A, there's one that says change. It says log base, and the base is all caps. That will change the base for you. If you have an 83, the only way to evaluate this is to do the log of 24 over your log of 4. Okay. Now that's changing it to base 10. I said here you can change it to any number I want. So I also could take this and say, well, I want it to be a base E. Okay, fine. Natural log of 24, natural log of 4. Maybe you want a base of 7. All right, so I want log base 7 of 24 over log base 7 of 4. And these, if you get the decimals, all 4 of these are equivalent, and you could change that 7 to any number, positive number you want, and you would still get the same output no matter what. Okay, and that's your change of base formula. All right, second one is your product rule, and as you would expect, product has some type of multiplication in it. And in this case, your multiplication is inside your log. So the rule or property goes like this. So I have log base b of r times s. That's an s. And when I have that, I can actually split this into 2. So I can make this log base b of r plus log base b of s. Okay, some things that are important, whatever your base is, has to remain the same. You're not changing the base on here. All you are doing is splitting up this multiplication within a log, and then you add those 2 logs separately. Okay, so for example, on this one, I have the natural log of 4x. I can switch to the natural log of 4 plus the natural log of x. Okay, and this is helpful because then I can evaluate natural log of 4, that's a number, and then use it however it's asking. A possible way would be with transformations. This would just be up natural log of 4 from your original natural log of x. So that could be one way to use it, or just solving something along the way. All right, C then is your quotient rule. And so you're going to imagine you have division in there because it's got a quotient rule. So your property is log, still have to have a base, so we'll say base b of r over s now. Okay, and that thing is going to split just like multiplication, except we are going to subtract. So log base of the numerator, so r, of b, oops, I got to move that. Get my pen back, there we go, of s. Okay, so when there is division, I can split into 2 logs with subtracting the log of the numerator minus the log of the denominator, again maintaining whatever your base is has to stay there. Okay, so one thing that students sometimes struggle with is they, especially without these parentheses here, this x over 13, or 13 over x, is all inside log. And then now I can use my property. If it looks like a 13 times and then an x dividing all of that, it gets tricky. So just be careful with where are parentheses on these. So this is a common log because there's nothing there, so it's base 10. So this would be log of 13 minus log of x. All right, your power rule. So this is going to have some type of power involved. So it's going to look like this. If I have a log base b, we're going to use r, and then we're going to put the power on that thing that, or that input in your log. So we'll put it on r. What I can do is I can take that power and I can shift it out front to multiplication. So it equals t times log base b of r. Okay. So using that in here, my base is 11. Here's my x cubed. So that cubed can hop in front and just be 3 times log base 11 of x. Oops, that's an 11. Sorry about that. Of 11. Okay. Now we're almost done here. One very important thing is that all of these properties, all properties work both ways. So you will be using these, the way, so for example, in D here, I might give you something that's 3 log base 11 of x and need you to put that 3 back as a power. Or, an example of going the other way of your product rule. So maybe you have log base 3 of 7 plus log base 3 of x squared. I can go and I can say, oh, I'm adding, I have the same base, very important. I can put this together to log base 3 of 7x squared. And this is the practice that we want to do live. We don't want to do over a video because it gets tricky of which property is where and what are my bases and all of that. So we will work through that part together. So thanks for watching. Make sure you bring your notes to next class Monday so that you are ready to do examples. Without these properties, you're not going to have it memorized yet. So you're going to need this note packet out. You're going to want to reference it and compare and look at what we're doing. Plus, obviously, the examples are in this note. So please make sure you have this ready to go for class. Thanks for watching.